Today's topic is about synchronized statements. We already know we can declare a method as synchronized. When we do so, we are saying whichever object calling this synchronized method work as an intrinsic log for this method. We don't have to specify which object used as a log. It have a default value. Another way to create a synchronized code is with synchronized statements. Unlike synchronized method, synchronized statements must specify the object that provides the intrinsic log. In this example, those two statements are synchronized statements. Synchronized keyword have to specify which object work as a log. This keyword means the object containing @name method work as an intrinsic log. Synchronized statements are very useful. It allows our program to fine-tune the performance. Here is an example. In the public domain, we have the source code of Java concurrency in practice. 2.8 servlet that caches its last request and result. The cached factorizer extends generic servlet implements servlet. They are defined in JavaX servlet package. In order to implement servlet interface, we need to provide a service method. Both servlet request and servlet response is defined in JavaX servlet. First, we extract the big integer from the request. Then we increase the hits. In the next step, we tell if we already cached the factor of the lost number. If yes, we get the cached factor. Otherwise, we calculate the factor. Then we update the lost number and lost factors in a pair. Finally, the factors are encoded into response. Here are the spaceholder functions. Let's examine those synchronized statements. First, we increase the hits so that later we can get the hits and get the cached hit ratio from the synchronized methods. They share the same log and is safe. And next, we compare the lost number with the current number. If they match, we get the lost factor from the cache. What happened if we don't synchronize? One scenario could go wrong is, after execute this if statement, another thread gets a CPU cycle and run this code block. So lost number and lost factors are both updated. Then the CPU cycle is returned. The previous thread go ahead and get lost factors. It gets the latest factors. However, the I is compiled with a stale value. It's supposed to be the latest lost number, but it's not. It's equal to the previous lost number, and here is a mismatch. The I is stale, factor is the latest, and you get the wrong answer. In the next statement, we get the factor. The factor is a heavy calculation, so we don't synchronize. Otherwise, the performance will be harmed. All we need to do is update the lost number and lost factors in a pair. What happens if we don't update them in a pair? One scenario could go wrong is, after run this statement, another thread gets the CPU cycle and run this statement. It tells the lost number is equal to the current number. Then it goes to fetch the lost factors. Here is a problem. Lost factors haven't get updated yet. So what you get is a stale value for factor. And the I equal to the latest lost number, but the factor equal to the previous number and you get a mismatch, and the answer is wrong. Again, in order to get the correct answer, you need to synchronize both these statements and these statements. In the next section, we will write a test bench and drive this class.